Hello guys, welcome back. This time I want to show you a small example about how to communicate on Arduino board with serial UART communication with a C# Windows Forms application. I hope you will enjoy it. So we'll use the same board we will working in the previous example. You know this board, maybe you have already assembled. I have it here, as you can see here. Uh, So it's the same. We have here the servo motor, the push button, the LED, the potentiometer, and our Arduino board. So if you don't have already disassembled, I recommend you to start doing it. So I'll start by writing a small application about turning on and off a small LED. This LED is connected to the pin 8. So I would write down here 8. So what else we need? We need a BIOS setup, and we need to start the communication. Also, we need to set the pin mode to an output. Okay, that's it. Now the boil loop, which is our infinite loop. We are going to be waiting for something coming from the serial port. Oh, I almost forgot here. We need, oh no, yep, we are starting the serial communication just just above that line. Okay, so we need a switch statement for switching between all the commands that will be coming from the serial port. Okay, and a case statement, as we used in the previous example, we'll use an A for turning on the LED. Oops. Each case statement needs a break. Okay, it right pin LED as high, and a B for turning off this LED. Let's see how this works. It will start uploading here the program to the Arduino. Yes, it did. So I'll open a serial monitor. Remember to set it to this baud rate here. The same night is here. So I'll write down an A. Oops. Oh, it's turned on. Enough. On, enough. On, enough. Okay. So this is working. I'll now start writing a small application, small Windows Forms application. So open Visual Studio and let's go to a new project. This project will be Windows Desktop. Remember to have selected here the C# option, Windows Forms application. I'll leave it with this default name here. You can change it, or I don't know, example 1 or something do you like. So okay, we have here our forms window. I will dock my toolbox board here so you can see it, and in the all Windows forms I will drag and drop two buttons, just two. Okay, I will rename these buttons in the properties bar here. You can access also this properties bar by right clicking the button and hit here properties, and I will change the name of the button underscore uh, LED on. Also the second one underscore LED off. Oops. And change the text. So okay, what will happen when you click this button? We will add an event handler here. Just double click and this event handler will be added here, and we need another one for this. Okay, so now we need a serial communication. Here in the example, I'm adding some serial communication using uh, using this serial port class. You can write this serial port class and then create an instance of this class using these uh, these sentences, but I will go for the easy way in this example. I will go just searching for the serial port here, and I will drag and drop to my Windows forms. Here you will find this serial port object. You can right click and see the properties here. We need to change this baud rate though to the one we have in our Arduino code, and the serial port the serial port name property, we'll need to set it to the same we are handling here, serial port com3, serial port com3. Okay, now we are all set. Now we need somehow to start this communication, to open the port and close the port. So I will right click my form and I will create a new event here, a load event and a form closing event. Okay, so this event is executed when the form is being built. So I will write here serial port 1, which is the name of my serial port, dot open. Okay, serial port 1 dot close. We need to open and close our serial port when the form is being loading and closing, just for handling correctly the serial port. And now we will handle these clicks. When the user clicks the button LED on, I want to turn on the LED, and which is my command. It's serial port right, right and A. And for turning off my LED, I want to write a B. So I'll start this application and it will try to open the serial port immediately. Remember to have connected your Arduino board, and so it's here, so it worked, it connected, and when I close this it will disconnect from the Arduino board. So this is working. Remember, it will work exactly the same as this serial monitor here, where you will be able to turn on and off, but clicking buttons instead of sending the commands directly through this bar. So I go here again, here is my screen, and here is the board. So I will turn on the LED, turn off the LED, turn it on and turn it off again. So we're good to continue with this. The next thing to do is to control this servo motor, writing a PWM square wave. So I will close this here and I'll go to my Arduino code. So I'll add a new case statement with a C and a D command. Oops. I will copy and paste. Copy and pasting is always better. A D. Oops, a C and a D. And I will create another function here, void increase servo, and I will need a variable. Also, I need to declare the pin where the servo is connected, and this pin is the 13 pin servo 13. Okay, we need to declare as an output pin servo output. Cool. Also, we need a variable. We need a variable for holding the PWM value all the time, so we can use it through all these functions. And I will set it to 0 just for initialization. So each time we send a C, we are going to increase the servo value, and this is the PWM value. So I will increase by 5 in steps of 5 and 5. And I need a check because I don't want this PWM value here to increase to an incredible big number. I just want to set some boundaries for this one. If this is bigger than the maximum number for 8-bit resolution, which is the resolution of this PWM for this Arduino, I will set it and I will leave it with this value. And I need another function, or actually not another function. I will just write here this PWM to the servo, and I need another function for decreasing. So instead of increasing, it will be decrease -5, and when this value is starting to going down to the negative side, so is less than 0, I will set it to 0. So this value will never go less than 0 and never more than 255. Okay, it makes sense to you? It should. Copy this function here, colon, copying this other function here, and semicolon. Okay, so we are ready to test the servo. So I'll start testing the LED. Okay, it works. So I will increase the servo value. It starts to move. Okay, that's cool. It makes an annoying noise actually. I will write here just at the book line, just to know which value I'm having right now. Sorry, it's not right. It's print line. Here and here. Okay. A and B. Okay, C, it's set to 5. 10, 15, 20. It starts move in the 100s, in the 200s, and then it goes crazy. Okay, it just try an error, guys. As you can see, you cannot go up from 255, and you shouldn't go less than 0. I'll start decreasing, and the program shouldn't let you less than 0 here. Okay, as you can see, it is set to 0. Okay, so we have it working. We need to delete this because we don't want to catch this value in the program, not now. Or maybe we could. So I'll delete these ones. We don't want to receive this in our C# program. I will load this to the Arduino, and let's go back to our graphic user interface. I will drag and drop 2 more buttons. I will rename this button to PWM something, PWM++ for increasing PWM. And also I need to change this name, button underscore something meaningful increase. PWM increase, it's a better name, PWM increase. And this other button to PW underscore PWM decrease. Okay, awesome. I'll need to change the text to PWM minus minus for decreasing. Double click on it to create a new event. Double click on it too to create a new event. And we need to send an D and C just in the same way we are sending A and B. Here we are. C and D for increasing and decreasing. So I'll run this application. I'll put the camera here. Yep. For increasing and for decreasing the PWM. LED on, LED off. Okay, this is working. And right now we need to catch some analog values. We need to catch some digital values actually. So the first thing to do to catch this push button here, or to read what the push button value is, first I need to declare the pin where the push button is connected, and this pin is the pin 4 in my Arduino Mega, and I need to declare this pin mode as as an input. Okay. Then I need to somehow read this digital value. To do this and to do this in a convenient way, I will better write down a function for read this digital value. Read digital value. And I won't directly write whatever is in the pin into the port. I prefer to send a customized string like this one. For example, if the digital read for this pin push, which is the pin number 4, is true, I would like to send through serial the word hi. Whenever the push button is not pressed, I would like to send low. And I will copy and paste this function here in my case statement. Oops, not here, but here. Remember guys, copy and paste. Which command is the next? The E, A, B, C, D, E. Up, semicolon. Okay. Everything is good? Yes. I'll test it using the serial monitor. Okay. I will read using an E. Okay, it says it's low. I need to push it here with my hand, and it says it's high. I stop pushing it, and it's low. Okay, everything is working. So let's go to Visual Studio, and we need to add a button here and a label. Label in the L is here. Okay, I will change the name of this this button to digital. Button underscore digital. And the text is, oh jeez, I changed it correctly. Read digital is the text, and the name is button digital. I will also change the name of this label to label digital, and double click this button to generate a new event handler for the click event, and we will send an E, and immediately we know the Arduino is going to answer everything I sent. So I will set this to my label. I will read the line. This option will automatically read the line and set whatever is reading to the text of my label, which I mean here. So let's test it. Here I have my screen, my beautiful window, and I will try to read something. It says low. Awesome. If I push again, it will remain as low. But if I push my button, it says high. I release this button and it'll change to low. Okay, so this is working, guys. The next step is to catch some analog values. So the first thing to do here is to declare the pin where the potentiometer is set. In my case, this pin is the analog port is the port 0 in my Arduino Mega. So I will also write a function read analog value for reading this value, and whatever is in this port, in this analog port, I want to send it over the serial port. So also I need another letter here, A B C D E F, and I will copy and paste this function here. So that's it. Let's test it. Okay, open the serial monitor and an F. Okay, we have an F. I will move just a little the potentiometer. Okay, it results I move to the maximum. Okay, I will move in the other way. Okay, I will decrease a little more and decrease. Okay, still decrease a little more. Okay, we'll increment. Okay, it's working. Now guys, we need to catch these values in our Windows. So let's go back to Visual Studio. Let's add a button here. Okay, and another label. Okay. I will rename this button to button, oops, this is the text, read analog. Okay, read analog, and rename the name of the button to analog. Double click in this button here. Oh, the label, I will also need to rename the label just to have everything in order. Double click the read analog button, and we need something very similar to what we did here, but instead of sending an E, we need to send an F to execute the F command, and instead of pointing to the label digital, we want to point to the label analog. So let's test it. I will run the application. Okay, it's here, and here's my Arduino. If I read digital, it will still work, or it should. And if I read analog, you see how this is changing a little bit. This is because the values are not stable. I will increase. Okay, we have some noise in the potentiometer because this value is changing. Okay, I will increase a little more. I click again the button. Okay, it changes. Increase a little more. I click again the button. Okay, it changes. Decrease the other way around. Okay, so it's working, guys. We can catch some analog values here. I will close this application. Okay guys, so now let's do something a little bit more complicated. Here you have the example to extending functionality using a timer. So do you remember how we need to click this button each time we want to read some analog value? Why? Because we have here a button event that is sending the F, but we don't we don't want to do that all the time. And maybe if we can find a way to let the program itself send this command periodically, so we can start reading periodically the value, that would be the best option. And to do so, we need something called a timer. But first, we need to get rid of everything that is the digital lecture. We are going, just for the sake of this example, read only analog values, so I will delete everything here related to digital. I will delete these buttons, and also I will delete this method, which is the digital method. So okay, our code is not pointing to anything related to the digital thing. And also in my Arduino code, I will delete the read digital and only leave this read analog value. Also here read digital, so you won't confuse, and the program won't be confused with everything that is going to be sent automatically to the program. The only thing that is going to be sent to the program is this line. This line is going to send the analog value. So here we go to the our Windows forms, and we look for something called timer. This timer has a very interesting function. It will declench or trigger an event. Here the event tick. Here I created the event tick. It will trigger this event from time to time, and you can configure this behavior here. We are going to trigger this event each 100 milliseconds. I will set this to 500 just for this example, and I will write here a little test function, message box dot show. So as you remember, this message box pop-ups a new message. I will put hello tick, and I will run this application. Oh, it won't work if I don't start the timer. I will put, oops, I created accidentally a label click event. I don't want this label click event here, so I will just delete it here. Jeez, come on, Visual Studio. Okay, it's done. I need two more buttons here, one for starting the timer and one for stopping the timer. So this button here I will rename to let's find a clever name. Analog start. Or start reading and stop reading, because it will read the analog port. I will also rename this to something meaningful, analog start something, analog stop. It's just to say that we'll start the timer and we will stop it. I create by double clicking the event handler here, and I will timer 1, because this is the timer 1. Timer 1 dot enable equal true, and timer 1 dot start to start the timer. And when I click the stop button here, timer 1 dot stop, and just because I like to do it, it's not mandatory, I will also disable. Okay, let's test. Okay, have it here. Remember, it is still open in the serial port, so you need to have your Arduino connected. Start reading, and it will start popping up everything. Okay, I will stop that because I don't like too much Windows. I will change to something more manageable for me. I will change this interval to 2 seconds. Okay, I have here, okay, 1 tick, 2 seconds, the second tick. Okay, you can see how this works. I will stop the timer, and no more pop-ups. Okay, so it works, but I will need to change this for whatever is here. Instead of sending this serial port right F each time the user clicks a button, actually we are going to get rid of that button. We need to send it every, let's say, 300 milliseconds. Each 300 milliseconds I want to know what the value of the analog port is, so I will send the F command to the Arduino each 300 milliseconds, writing it down here, and I will get rid of this thing also by this button is no longer needed, which makes this method no longer needed too. But the tick option is kind of dangerous because it will be executed uh, each 300 milliseconds in a 300 milliseconds interval, so and you won't be able to stop it if something goes wrong. So I will add some checks here just for checking if the serial port is opened. Why? Because if the serial port is not open, you won't be able to stop the errors coming and popping up all over your window. If for some reason the serial port is not open, I want this timer to stop, just to stop. And as I said before, I want to disable it. And I want also to show a message. The serial port is not open. For some reason it's not open. And I will close the window. Okay. So each 300 milliseconds this command will be sent to the serial port if the serial port is open. Okay, we are good. Now there is an event for our serial port. So instead of trying to read the serial port each time we send this command, which is not good because sometimes the Arduino can be delayed or be processing something and it won't send immediately the value of the analog port through the serial communications. So it's dangerous to have something like serial port.read line here, because that can break our code apart, that can throw an exception if there is nothing to read. So it's better to handle the reading in another thread, in another part, and the best way to do that is using an event the serial port has, which is this data received. So double click this to generate this data received. This method will be executed each time the serial port has something in the buffer, in the income buffer. And that means that you have received something in the serial port. You see, each 300 milliseconds you will send an F, and you won't be waiting for something in return. Instead, you will have this method to handle all that hassle for you, all that communication, all that um, income from the serial port will be handled here, which is better. So first, uh, we need to instantiate, serial port. I think I'm missing something here. Oh yeah, .io dot ports. Okay. Serial port, my serial port equal, I will cast the serial port from the sender. This sender object is my serial port. I could also have do that serial port one dot something readline or do something, but it will throw an exception. So it's better if you cast the serial port from the object sender. It's exactly the same. So I will need to read a string of data. This data is the analog value received from the Arduino. So each time I receive some data, I will do here an analog conversion, because this data is now a string, because this read line returns a string. So I need to do a conversion first. Data. So just in order for you to know what are you receiving here in this serial data receive method, I will write down here a little debug line. Write a line. Write line. Analog ball. Okay, so we are writing to the console each 300 milliseconds. I will start my application here. Here's my Arduino board, and you cannot see here the complete console. I will pop up this console here so you can see everything. I will start reading, and here you see the analog value. I will move this thing here. So each 300 milliseconds our program is sending an F command. You can see how the serial port LEDs are very busy receiving and sending commands here, that you can see here. And I move the shaft of the potentiometer, it starts changing on the console. So okay, this is working. So let's move on. So I stop the debugging, and I will get rid of this line here because it was just for testing purposes, and I will go back to my window. So I hide it here, the property, so it won't be uh, consuming space, and I will make my window bigger, kind of bigger, because I will also hide this. Okay, now it's bigger. I will make it kind of bigger. Okay, I will move this here, here, so they are not. So we have more space here in the center, and I will go for a control in the data data model here called chart. This chart will let me make a nice chart, as its name says, of the data I am receiving from the serial port. So click in this chart, right click property, so you can see here, I will dog it again, and look for something called series. Here we have it, series. Click series and change the column for the SP line. The SP line is better for the kind of work we are doing here. So we are going to make a nice chart of the analog values. So it will look like a square wave here. Not square wave, sorry, and a signal, the way of the signal here. So now let's go back to my so here in my code I will write a new variable, a new private variable here called oops, private the value of this variable, sorry, the data type of this variable is a queue, so I need a collections that generic. If you know what a queue is, just imagine the queue if the bank people is coming from the end of the queue, and the first people to come is the first people to go outside. That's a queue. You can Google it. A generic queue of integers. Here it will be samples, meaning samples of data. Also, each time I load the window here, I will create a new queue. Samples equal new queue of integers. I will put 50 values for initialization, and each time something is being received from the serial port, I will add these values to my queue dot enqueue. I will enqueue this analog value. You can imagine this queue just as a list of values, okay? This samples is just a list of analog values, and I want each 300 milliseconds in this tick event to chart, to make a chart of these values. So I will create a new method, private void chart refresh, and I will put this chart refresh here. Chart, I will call this method here, and this chart refresh, what it's going to do is just to write all the values into the chart again. I will first clean all the points, and for each value in my samples queue, what I want to do is add that value to the chart 1 dot series. What series? This, the first one, dot points dot add y sample. Okay, as you remember from the first lecture, the for each loop is going to iterate between all the samples in this samples queue, and it will add this new value, this new sample, to the chart. this is going to happen each 300 milliseconds. So let's see how this is working. I have here this and my Arduino board. I start reading and you can see how this is incrementing. I will change my values here. Okay, do you see something strange? If you look closely, this number is it keeps increasing. So what does that mean? That we are not leaving values behind. We are just storing and storing more and more and more values. Right now we have more than 60 values in the queue, and it will keep increasing and increasing. And as you can see, the chart is started to shrink because we are not leaving values behind, and until we have this kind of error we cannot perform uh, more than it took more time than what's expected for this chart to refresh. So in order to avoid that kind of errors, what I'm going to do is write another function called enqueue sample. It will receive a sample as a parameter, and what this thing is going to do, it will start uh, reading how many samples this queue has. When the queue of sample has more than 50 elements inside, what I'm going to do is sample.thequeue. I will delete the first element in the queue and then I will add this sample here. Okay, so when the queue reach 50, it will throw away the first element and it will add the element I'm passing as parameter to the end of the queue, and I will call this from data received here. Instead of enqueuing myself in the queue, I will call the enqueue method passing the analog valve as a parameter. It surely will fix our problem. I will reboot my Arduino. I'll start again my application here. I have it here and I will start reading. So it's nice, it's better now. As soon as it reaches the 50 values in the queue, it will start throwing away all the other values. Let's wait for the 50. Okay, you can see it got stabilized in the 50 values. Now all the values here are going to be thrown away, and new values coming here are going to be preserved. So this is working now as expected. And you have a nice chart here. I will stop my application. And that's it, guys. That's what I have for today. I hope you have enjoyed it. Well, see you next time. Bye bye.